Amazon machine learning. So there is a definition that I'm gonna just kind of read off the Amazon website because it just kind of summarizes the whole thing. Amazon machine learning is a service that makes it easy for developers of all skill level to use machine learning technology. Amazon machine learning provides visualization tools and wizards that guide you through the process of creating machine learning models without having to learn complex algorithms. Once your models are ready, the process makes it easy to obtain predictions for your application using simple API without having to implement any custom solution as for the infrastructure or implementing the algorithms. So having said that, let's move forward a little. So I'm going to just touch upon a little bit about the introduction and the types of learning model that Amazon provides. A very high level idea of a high level view of learning algorithm, how exactly it computes the learning model, and some of the parameters that you can configure to fine tune your model for predictions. And then model evaluation, whatever model you create, how to evaluate it, and how to look into more of a graphical view of those evaluations. And at the end, we'll do one short demo. So as for the introduction, Amazon provides pre-built machine learning models to apply on a data set in order to predict a target value. So now, what sort of data set? So a data set with an n number of variables contributing towards an outcome of a target value. So you have a data set, and at the end you are trying to predict a target value or some kind of an outcome. So as an example, let's take a look at bike sharing data set. I got this data set right off of machine learning repository where there's a huge collection of machine learning data set that you can get for POC purposes. So this particular data set has a problem domain to say that they want to predict how many number of casual bikes do they need at a given time. So in order to solve that question, there are certain variables you have to consider, and some of those variables are right up at the top. There's a time of day. There's a season, holiday, whether that's a holiday or it's a working day, a temperature. A temp is more of, I think in the notes it says feels like temperature, the humidity, wind speeds. All these factors are contributing towards how many bikes do you need to provide to fulfill the demand. So that's kind of like the structure that Amazon machine learning model is trying to solve. So in this particular case, we are looking to get a target numeric value. So how many numbers are there? But there are a couple of more models that Amazon provides to solve, and the example is binary classification model. So the example would that be, will the customer buy this product or not? So we are predicting one of two possible outcomes to using this particular model. And another model is multi-class classification model, which is predicting one of more than two possible outcomes. So the question that they would try to be solving is that is this product a boat, movie, or a clothing? Or is this movie a romantic comedy or documentary or a thriller? So you have some certain kind of classification that you are trying to put your product into. And the last classification model is numeric regression. The bike sharing is a numeric regression model. That was one of the examples for it. And so let's move on. So the next is, let's look into how exactly Amazon computes, how it generates this learning model. So Amazon uses a linear model to learn the training data. Based upon training data, the learning process computes one weight for each feature to form a model that can estimate a target value. So here's one example. So you are trying to estimate how much of an insurance a customer will purchase. So for that outcome, you are considering two variables, age and income, and there can be n number of variables. So if we have like two-dimensional requirement, it's easy to graph, or three-dimensional. But when you have n number of variables, it gets very hard to compute. So to solve that, so that's the linear model. What it's doing is putting two things on each side of the equation. So there are contributing factors that are contributing towards the target value. So we have certain weight that is assigning to each feature, like age, income, and then at the end it's estimating a target value. So what Amazon does is that it takes the training data set, and it's basically it's a supervised learning technology that it's using. So you provide a data set where you know the given features or the variables contributing towards one target value, which is kind of very much supervised in the sense that you have vetted it out, and you know this data is what you want to base off of your prediction from. So what the process does is it divides so you upload the data set, and then it divides into two pieces, 70% and 30%. So what it does is that it goes over the 70% of the data set, and it learns how your variables are contributing towards your target value. And based on whatever it has learned, and then it applies onto 30% to evaluate how effective is its learning. So there is a loss function built into the process, and the loss function calculates the difference between estimated target value versus the actual target value. And each model classification has its own loss function built into it. And for the optimization technique, AWS uses stochastic gradient descent technique to optimize the learning model. This is a mathematical heavy term, and that's kind of like it takes away from you and helps you, it implements, and then it kind of provides a built-in solution for it. So what SGD does is it makes multiple passes over your data sets with varying weight size for each variable, and it tries to predict, it tries to calculate the target value, and then it checks against the rest of 30% to see how much accurate it is. So far we have seen the introduction, like what kind of models it provides, and the learning algorithm, level of the learning algorithm, how exactly it computes. So the next is it provides certain parameters that you can vary within the process to optimize your learning model. So one of the parameters is a learning rate. So the SGD algorithm, it iterates over the data set, and what the learning rate defines is that how it varies the feature weight when it's iterating over. So if you set your learning rate too high, then it may cause the process to overpass the optimal value. And if you keep it on the small side, then it requires multiple passes over to the training data set. So number of passes, you can restrict how many number of passes does the process makes over to the training data set, because depending upon your training data, it can be a lot of passes that it has to go over. So usually it is, what I read is, over a large data set, it may be that you need less number of passes, and over a small data set, you may require more passes to learn the data. And it really boils down to what kind of data you are feeding in. So garbage in, garbage out, gold in, gold out. So that's pretty much what it boils down to. And the next parameter is the model size. So when it's iterating over to the data set, it's obviously it's creating a model size, and it can be very big based on your data set. So Amazon provides another parameter that you can set your model size, and if it is too small, the concern is that your learning model is not as effective. And also it is recommended whenever you are feeding your data set into the learning process, you shuffle the data. So for example, if your data set is very onto one side, or it's kind of sorted, for example, to with the price or to the number of bikes that it needs. So then what would happen is that when it's making a pass over, then it's learning one type of data set. Rather, we need to have like shuffle it so that it encounters different kind of data sets, so that it learns effectively different variation. So the next parameter is regularization. So this is another mathematical term. What this does is that it prevents the linear model from overfitting the data set, overfitting the training data. This is how the process assigns the weight to each feature set, and it kind of calculates what's the variable contributing towards the target value. So this is to reduce the background noise, in the sense that if the variable is not affecting too much, then give it a lesser weight. And if the variable is contributing towards a target value with a bigger delta, then assign it a bigger weight. So having said that, so now we can look into Amazon provides a graphical interpretation of your training data to see how effective your data is. So this is one of the example of binary classification model. So in this case, we can see that if we, so this particular curve shows that it's a all the true known real answers 0. So these are negative answers, but they are matching to your towards your actual target value, and vice versa on the other side, that these are true values and they are matching to the data set. However, the overlap is where the model is unable to predict, or whatever it has learned, it's not according to the data, the training data set. So the idea is that the shadowed version has to be, if the less of the shadow, the shaded area, the better your learning model is. And this particular example is a multi-class classification model evaluation. So it kind of tells you where it's unable to predict certain values and how many values it was successfully able to predict, whether they're negative or positive. And this particular one is numeric regression classification model evaluation. So the idea is that the term that it throws is on the 0 scale. I'm not sure if you can see on the 0 scale, it should make a bell shape that on the 0 of x-axis it should be highest, and then it should drop down on either side of the edges. So having said that, now I can just walk into a little bit of the demo. I have a demo created, which I have built the whole model, and depending upon time, once we go through the existing model, then perhaps I can go over the steps to create a new model, just to see some of the configuration. So I am logged into the Amazon machine learning, or I'm not. Let me just log in real quick. And machine learning. So this is the repository that I got from the open source. It's a stale data. Let me just show you the data set that I have. And this is obtained from the open source machine learning repository. So it's a stale data, and I'm not sure the accuracy of this data, but for POC purpose, I just kind of use it because I have a good amount of variables available and the values filled in. So we have I think normalized losses, it talks about the insurance losses, like what effect would this particular car will have on your insurance price, the make, gas, and some of the variables going up at the top, and at the end we have price. So this kind of lies into the numerical regression classification model, where it will learn the data using these variables and predicting a target value, that is price. So I have uploaded the data, and again I will go over the steps, how to create a data source, model, and evaluation. But just for this particular demo, I can go into evaluation just to show how to evaluate the existing model. So this creates root mean square error. So it says that if RMSE is lower, then it's a good model, and it compares it against the baseline. So the lower the RMSE is, that means that lower are it was able to successfully predict the values. And it just kind of go over the graphical view of it, and that kind of shows where the prediction was less than target versus where the prediction was higher than target. It doesn't exactly make the bell shape, but it's kind of close. So having said that, let's go into machine learning model. So this shows what type of model it recognized looking at the data set. It's a numerical regression. It got its data source, some of the parameter on the data source, which particular data source is connected to, and then Amazon provides how you can predict your values. So you can do a batch prediction, where you can upload another file and it will just batch predict that particular data set, or you can try a real-time prediction. So I have one bracket that I can just try to show. So it predicts that this particular car, Toyota, given all the variables that we have here, it predicts the value of the car. Obviously, it's a stale data. We can't make anything out of it, but it's just to show how exactly it works. We can change certain parameters and we can see the price move. So, for example, just change the make of this particular data set, and the value of the car goes up. So I want to show you one piece, how exactly it assigned those weights that we talked about in the linear model. So you can go into your data source, and it divides, as I said, divides the data source into two pieces, 0 to 70% and 70 to 100%. So if I look in the first batch, which is the training data set, it tells me, it can show me how much weight it assigned to particular feature or particular variable. And we can see that for the make, it has given more weight than anything. And we saw in the demo that if I change the make, the price goes up. So that's a real-time prediction. And there is one more kind of prediction we can do. It's a real-time prediction. So for example, in our domain, if we were to create some sort of training a learning model in Amazon, we can expose that learning model through an endpoint, and then we can hit that endpoint and get the result. Just to demonstrate that, so I have already created an endpoint, and I have written in Java a small piece of code just to show how it may work is, I got two records. I got Mercedes and then I have Toyota, just to show the difference. And Amazon provides their own SDK that you can kind of incorporate with your own code. I create a prediction record, prediction request, give it a record, and the record is what I just showed you, the vehicle with just a map, key value pair. And so for this particular Mercedes, if I run, I get my predicted value. And if I were to switch off another one, the value changes. So having said that, let's take a look into little bit into actually there's one more thing I would like to show real quick. So Amazon provides its own security. So even though I'm exposing this endpoint to outside world, but that doesn't mean that anybody can hit that endpoint and get the record. So there is certain kind of security that you have to configure for it to work. I'm not sure how many people has worked with the security with Amazon. It kind of creates a credential file in your root directory that it reads your access key and your ID, and that's what it authorizes against on Amazon. And as for giving access to that particular resource, if you were to go into identity and access management, go into policies, and so this is the particular policy that I have created. It's just a kind of a JSON object that you can give. I'm giving in, I'm allowing an access to myself on this particular resource, which is kind of like a very, this is a particular format that Amazon provides, and then the region spaced with the model ID that we saw earlier. So you have to kind of create your own policy and then assign it to the user. So I have assigned to myself, and that's how I'm able to hit that endpoint to get the result. So that pretty much concludes my presentation, but I can just show you a little bit on the steps that how to create a particular machine model. So the first thing that we have to do is we have to create a data source, which can be an S3 storage, or it can be, I'm not sure if it can connect to any of the database, but you can have an S3 storage. That's what I have. You can upload your file. So I created my bucket for my POC, and I have uploaded my files. And once these files are available in the S3, then you can go into Machine Learning Console. And it's just a wizard that you start from here, create new data source and ML model. It can be Amazon Redshift and S3. I give my bucket name that I created in S3, and I can assign my data source. Just to give it a different name. So the first row is the heading, and it reads that, and then I can define what type of column it is. It can be categorical. For example, Toyota, Mercedes, these are categories. So for the most part here, these are categorical the information, and there can be a numerical field. Wheelbase is a numerical field. There can be binary, or I can define my categorical to be a text field. So and the next step, we have to pick our target column. So what we saw earlier with the bike share example, that there were certain variables, and at the end you are predicting how many bikes do you need. So that's the last column. And in this case, we are predicting the price. So I can select price to be the target value, recognize that, and does your data contain any identifier, which is, I believe it's the row identifier, so I don't have that. Just the review page, continue. And for the most part, I'm using the default values. However, you can customize and you can vary those parameters that we went over, the learning rate, the model size, and the number of passes, and few other parameters. So I'll just go with the default. Just review over, it shows what exactly the parameters that is using. So at this point, it says pending, and it does take a while to create the actual model. At this time, it's looping over those data set and trying to figure out, it's learning the data set, how the variables are changing the target value. So while it's doing that, is there any question?
I was just thinking about how you might have cases where you might expect interactions between variables. Like, for instance, I might expect a used Volvo or Honda to do better on price than some other make. So is there a way to get at those kinds of interactions? I mean, because I'm thinking about, you could calculate a value based on both and put that into your data set, right? But I think that probably causes problems because those data points aren't independent from the other data points that they're generated from. So I don't know if there's anything in here that helps you get at that.
If I get your concern correct, so you're wondering the variables, how it's affecting the predicted value. So,
well, more about just are there any tools that let you get at interactions between variables, right? Because on the one hand, being a used car, just looking at being a used car is that's gonna decrease your price as compared to a new car, right? Whereas obviously different makes are going to have different prices as well, but certain makes might maintain their price better when they flip from new to used. So is there a way to get at those kinds of interactions?
So I think it really depends on your data set. So in that particular case, you would want to have the make plus what kind of vehicle it is. So you are adding more parameters into it. So for example, Honda seems to carry its value for the longest time. So obviously you have Honda when you are preparing your data set, training data set, you have Honda, and then it's carrying over for one particular, for example, sedan, for one body style, it's carrying one value. And on the other hand, another vehicle it's same category sedan and it's not carrying its value. Plus, given the age of the vehicle. So all these factors are contributing towards that value, and that value is predicting what kind of vehicle it is. So it's on both sides of the equation. So when it's learning those models and it's preparing itself to learn what kind of trend the vehicle is having, or what kind of trend the variables are having towards the target value. So the learning process, I feel like, it's built into the equation. So that's where it's more of a supervised learning idea comes in.
Again, along the same lines, can you have a model that's driven from two different data sets, kind of using the pricing predictive model? If you have the history of all of the used cars that we had for years, and a second data set that showed, say, recalls over time. So you would know the price of Hondas over time, and when the big airbag recall happened, it could show that there's a difference in the value of the used cars. Can you have a secondary data set that would have the influencing factors that might train the model for the predictive pricing?
Would you call another type of data set, or would that be a variable into that data set to say, like we have one normalized losses, so that is to say that's one.
Probably, unless you're going to have to, unless trying to figure out how to merge, sometimes the record sets can't merge easily together.
I feel like it should be one, well, I don't know, to answer your question, I don't know if it is possible. And just thinking over the question, it feels like it should be consolidated into one so that it has an effective learning, because the recall, it seems more like of a variable while you are considering that particular make at that point. So that seems like it should be a variable into the training data set that's forcing the target value to either go up or down.
So basically denormalize everything first.
Right. And it's not like one-time process. This is a continuous evaluation process that it seems like it has to be. So for example, in today's market, this is a still data, I believe this is like from 1985. So today, if we look at that data, it doesn't make sense, the learning based of that data. So perhaps what we want to have is a continuous learning. The machine learning itself, what you are feeding into that machine learning model. So you have to continuously evaluate your training data set and iterate over it. All right, so that's completed. Let's evaluate performance. I believe it's creating evaluation for this data set. That's why it's not showing much. If I go on the dashboard, I believe I would be able to see. Yeah, so the evaluation itself is in progress, but the model is ready. So, and we can go and we can create an endpoint. We can try our prediction or whatnot. And we can see we have already, this is the same data set what I used to create for the demo. So we can just kind of take a look at this evaluation. It does take a while to actually process the whole evaluation. And this is not a lot of record. Right now what I have is I think is like 206 records. So that's not much to have an effective learning. So in this particular numerical regression is you look at the RMSE value just to make sure that it should stay low compared to baseline. So that's it. Any other question? Yes.
So you are creating an endpoint, right? So whatever you are giving the endpoint, how it is validating? Are they creating any API keys, or whatever the endpoint you are giving, how it is getting validated? So for example, you are giving in two places the endpoints, right? So how it's getting validated?
So how it's getting validated is, let me just show you real quick. Let me find the correct tab. So that's the endpoint that it created. So when I hit that create endpoint, that's the URL it gives me. This is the URL that I'm using.
Okay.
And then that's the model ID that I'm using. So if I look in my code, so that's that URL that I'm feeding it into, and that's the model ID. So, and how exactly it's validating itself, I can show you real quick. So this piece is more generalized toward any kind of communication with Amazon. Whenever you are remotely connecting, or through your code you are connecting to Amazon or CLI for that matter. So so that's the credential that it saves to take those values. So your access key and your ID. So that's the user ID and the access key. So whenever there are about 3 different ways that it takes those values when it's sending the communication out to the endpoint. So it's taking those values, it knows who you are, and it kind of like packing it with your request and sending it off to Amazon. And at that point it validates, and then it authorizes the request. Any other question? Yes.
So there's a part where you were determining whether like the make would have a higher precedence over, like, I don't know, like trim or color. Is Amazon determining that, or are you putting that in there to say, hey, make has a higher precedence over what the price is?
So Amazon is doing that in the process, and I was curious about that question myself, and I did not see any particular. I wish there is a way that we can somehow configure in our customization, because it feels like that. I guess that will not be a supervised learning, but that can be another learning model where you define those target values. So it kind of goes towards giving you more control into the implementation detail, I feel like, and perhaps that's the reason we don't get it like right off the bat. There might be some other way of doing it through SDK. I'm just not aware of. Any other question? Well, thank you.